Well, I thought it was important before we leave the section on antiderivatives or indefinite integrals that we look at a problem of this type. This is a pretty common type of problem. Find the function f of x whose graph passes through the point 1 comma 3 and whose slope is given by f prime of x equal 12x squared minus 12x for each x. Well, basically what we're asking here is to find the function who goes through a particular point and has a particular derivative. The fact that the slope is given by f prime of x, that's really just the derivative of the function. And that's how we find slopes, isn't it? Now, before we start on this problem, I think it's good to recall something about the antiderivative. Remember what we say, and this is from what we've been doing, that the integral of f of x with respect to x is capital F of x plus a constant of integration, where this capital F of x, where capital F of x is an antiderivative, or is the antiderivative. I really should say and. Sorry about that, is an antiderivative of lowercase f of x. Which means, what does that mean? This means that if we take the derivative of the antiderivative, then we get the lowercase f. And so, see, this tells us we could rewrite this a little bit differently. We could say the integral of the derivative of capital F is equal to f itself. And that's really the bottom line of all this. Integration is undoing differentiation. Now, I see that we've got this written all in capital F's, but it really wouldn't matter what we call this function. This is basically saying the integral of a derivative is the original function plus a constant. That's really what that's saying, isn't it? So, we might come in here and we could say, well, what we could do is call this that the integral of the derivative of the function, that's normally the way we call them, isn't it, is equal to just the original function. See, we can do it that way. Now, here's where the piece of information we really need to use. If we want to find a function, f of x, what we need to remember is that we need to undo the derivative. And this is the piece of information we're actually going to use in problems like this. Now, the deal is, though, this integral is going to have a constant associated with it. And to find out the particular constant, to actually find lowercase f, we need more information, like a point that the graph passes through, so we'll know exactly what the constant of integration is. And here's what I mean. Let's get to our problem now. And we're going to use this statement to be able to do our problem. So we want to know the function f of x. See, that's what we're asked for. What's f of x? Well, according to this, it's the integral of its derivative. And in this case, the derivative, we're told, is 12x squared minus 12x. So f of x is the integral of 12x squared minus 12x. Well, we ought to be able to do that integration. When we integrate 12x squared, we have our 12, and then we're going to increase the power that is on x by 1, so we'll have a power of 3, but we have to remember to offset that new power with the reciprocal of it. And then here we have a minus, and we have our coefficient of 12, and we're going to increase the power on x by 1, so let's see, 1 plus 1 is 2, but we have to remember to offset that with the reciprocal of that new power. And then we have our constant of integration. Okay, so as we go back and simplify, 12 times 1/3, of course, is 4, so this is 4x cubed. And 12 times 1/2 is 6, so this is minus 6x squared plus our constant of integration. Now, here's where we are. We know that the function we're looking for is 4x cubed minus 6x squared plus a constant integration. So, in other words, there are a whole lot of functions that have this derivative. And we're looking for the particular function, okay, where 1 comma 3 is on the graph. Well, now, for a point to be on the graph means that when x is 1, y has to give 3. And, of course, the y value is actually what? It's f of x. And so what we end up with, f of 1, is what has to be 3. So that kind of gives us how we're going, that should give us the information we need. See, our question is, what is c? Well, based on this information, we're going to calculate what c is, because we know that if we put a 1 into the function, that's our y value, that since 1 comma 3 is on the graph, when we put a 1 into the function, we have to get a 3 value out. But on the other hand, if we put a 1 into the function, it tells us that we should get 4 times 1 cubed minus 6 times 1 squared plus c. So that's what happens when we put 1 into this function. We know that it gives us, by the definition, what we have on the right, but because it goes through the point 1 comma 3, we know when we put 1 in, we also have to get a 3. So it basically boils down to solving this equation for c. And so we would have 3 is equal to 4 minus 6 plus c. And of course, 4 minus 6 is negative 2, isn't it? So we'd have 3 is equal to negative 2 plus c. We'd add 2 to both sides. And we would get c is equal to 5. Okay. C is equal to 5. And so that tells us that our function f of x is 4x cubed minus 6x squared plus our known c value this time of 5. That's the function that has a derivative of 12x squared minus 12x, and it also goes through the point 1 comma 3. And we could check that out now. How would we check it out? We'd find the derivative. See, that's the way we would check it, wouldn't we? We'd find the derivative, and we'd also see that when we put a 1 in for x, we get a 3 out for y. Those would be the two checks, and that would be easy for us to check. I'll leave that for you.